Hello, in this video we will be talking about Chapter 3 functions, and in this section it will be 3.3. We will be talking about rates of change and behavior of graphs. So the objectives in this case, we'll talk about average rate of change of a function. We'll use a graph to determine whether a function is increasing or decreasing or constant. We'll use a graph to locate local and maxima and local minima, and also absolute maxima and absolute minimum. So here we go. So first, let's talk about rate of change. Rate of change describes how an output quantity changes relative to the change in the input quantity. The units on a rate of change are output units per input unit. So basically, what's going to happen is we're going to take a function, and over an interval, we'll say between these 2 points, you're going to find the slope of a line that would pass through these 2 points that we're talking about. So the average rate of change between two input values is the total change of the function values divided by the change in the input values. So basically, if you took 2 points on your function, no matter what shape that is, and you drew a line through it, find the slope of that line, and that is the rate of change. And so hopefully, slope is something that you found in the past. You find slope the same way here. You find the change in y's, y2 minus y1. So the y of the second point minus y of the first point. Delta y is another way to say it. And we divide it by the x value of the second point minus the x value of the first point, when we call that delta x. So delta y divided by delta x, that ratio is how we would find slope of the line passing through those 2 points. So let's start with one where it's not graph, it's just ordered pairs. And it says, after picking up a friend who lives 10 miles away and leaving on a trip, Anna records her distance from home. The values are shown in the table below. Find her average speed over the first 4 hours. So for this one, so for this one, we need to take, we're trying to find the average speed over the first 4 hours. So we're going to find the average rate of change over that first 4 hours. So we want to look at this point from the beginning to 4 hours later. So we have the point 0, 10 and the point 4, 2, 14. So at 0 at the beginning, she was 10 miles away. 4 hours later, she's 214 miles away. So we want to find the average rate of change. So here's the basic formula for that. It's the same as slope, which is y2 minus y1 over x2 minus x1. So if we want to label our x's and y's, here's an x and a y of the first point, so x1, y1, and here's the x and y of the second point, so x2, y2. So I'm just going to substitute those into the formula. So y2 is 214 minus y1, which is 10. On the bottom, we have x2, which is 4, minus x1, which is 0. So 214 minus 10 is 204. Over 4 minus 0 is 4, and 204 divided by 4 is 51. So the average rate of change is 51. Okay, so your turn. Try it. Using the data in the table, find the average rate of change between 2005 and 2010. When you unpause, so pause it as usual. When you unpause, we'll go over the answer. Okay, so let's first find our points. We've got 2005, and it's 2.31, and then 2010, which is 2.84. So we've got the point 2005, 2.31, and the point 2010, which is 2.84. And we'll label these X and Y of the first point, X and Y of the second point. So Y2, which is 2.84, minus Y1, which is 2.31, over X2, which is 2010, minus X1, which is 2005. So it should be Y2 minus Y1 over X2 minus X1. So we have 2.84 minus 2.31, and that gives us 0.53. And 2010 minus 2005 gives us 5. And then we divide 0.53 divided by 5, and we get 0.106. Okay, so moving on. All right, now we're going to do the same thing but on a graph. It says consider the graph of f shown below. Estimate the average rate of change from x equals 2 to x equals 5. So let's find the points. When x equals 2, that's this point. That's the point 2, 3. Now when x equals 5, that's this point 5, 7, I believe. So 2, 3, and 5, 7. So you basically go to that x value and then go up to the graph and find the point. So the first point at 2 was the point 2, 3, and the second point at 5 was the point 5, 7. So let's label these x and y of the first point, x and y of the second point, and let's fill in this formula. So y2 minus y1 over x2 minus x1. So we get 4 over 3. So the rate of change is 4/3. Okay, so you guys try this one. Compute the average rate of change from the graph given the function g of t. Find the average rate of change on the interval -1, 2. So find the point -1, find the point at x equals 2, and then find the rate of change. And then when you're finished, unpause the video and we will go over it. Okay, here we go. So -1 is the point -1 up 4, and then 2 is the point 2, 1. So we have our x and y of the first point and our x and y of the second point. So again, we're going to do the same formula. Y2, which is 1, minus y1, which is 4, over x2, which is 2, minus x1, which is -1. So I've got 2 minus -1. So on top, I have 1 minus 4, which is -3. On the bottom, I have 2 plus 1, which is 3, and I get -1. So the average rate of change is -1. All right, so compute the average rate of change of f of x equals x squared minus 1 over x on the interval 2 to 4. So in this case, we don't have a graph drawn. So in this case, we need to figure out what those points are. So this is kind of an extra step. So basically what we want to do is we want to find the function at 2, and we're going to find the value of the function at 4. So in this case, remember how we evaluated functions previously. Everywhere you see an x, you put a parenthesis and you replace inside that parenthesis, you substitute the value. So in this case, we're substituting 2. So we have 2 squared, which is 4, minus 1/2, and that would be 7/2 or 3.5. So this is the point, 2 for x, 7/2 for y. The second one, we're going to do the same thing, except we're substituting in 4 this time. So in this case, we have 4 squared, which is 16, minus 1/4. And 16 minus 1/4 is 63/4. And 63/4 is the same as 15.75. So it's up to you. You can write, for this one, this could be 3.5. And for this one, you can write 15.75. I'm okay either way. For the second one, this is the point 4 and then 63/4. So here's your x and y1. Here's your x and y2. So don't lose sight of what it is that we're doing. We're finding the average rate of change. So in this case, we're going to do y2, which is 63/4, minus y1, which is 7/2. And then for the denominator, we're going to do x2, which is 4, minus x1, which is 2. So on the top, we have 63/4 minus 7/2, which is 49/4, which is the same as 12.25 if you're doing it the decimal route, divided by 2. So 49/4 divided by 2, or 12.25 divided by 2, we're going to get 49/8, or we're going to get 6.125. Okay, so we're going to stop here, and we're going to pick up with the next part in the next video. That way you can take a break, and if you have questions, let me know.